Hey, what's up, AP Stats? This is the unit 4, oh gosh.
If you drive the white box truck that's in the parking lot, you have to move your vehicle at this time.
All right, number 16, here we go. Multiple choice, unit 4, chapter 6. All right, which is fine, we could be evaluated, used to evaluate the mean. That would be this one, that is n times p plus n times p plus x 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 times p. And a little test hint here. If you wanted to do this in your calculator, you could go in and plug in x into list 1, and you could plug p of x into list 2, and this acts as like a relative frequency. And you could do one variable stats with this as your frequency, and that would give you the average, and it would give you the standard deviation. All right, number 17. When you're combining two things and they are independent, that's the stipulation, they do have to be independent to be combined. So if I'm combining first half and second half and I want the new average, I just add these together. But can you just add the standard deviations? No, you cannot simply add standard deviations. To add standard deviations, you have to do this. It's actually a Pythagorean theorem. This is a 3, 4, 5 right triangle, if you can spot it. Anyway, you have to add the variances and then square. So you get the new variance, the combined variance, and then you square root it to get the new standard deviation. So keep that in mind for the test. You cannot simply add standard deviations. You have to combine the standard deviations using the variances and then find the overall new variance and take the square root of that to get the new standard deviation. Even if it's, so like this one was combining by adding, even if it's combining by subtracting, you still have a plus there every time because you're still combining variability, which will add variability when you combine. So in this case, number 18 was the events have to be independent. It's the only way to combine. They have to be independent. They can't affect each other. Number 19, which is following is the approximate distribution of the random variable x. Number 19 is a binomial. It does meet all the criteria of bins. So you can go through that. Number 20, this one was tricky. So they all have n equals 10, and it says, what has the largest value of p? Well, here's the distribution. So we have to remember about distributions that wherever the mound is, that's gonna be like the expected value, where they cluster. All right, so this one's clustering around 9, right? This one's clustering around 2. And for a binomial, the average is n times p. So if n is 10, we're just looking for a p. Well, that would give us, if this is 9 and this is the average, and then p must be 90. P must be 90% here, because 10 times 90%, or 0.9 is 9. Whereas down here, 10 times 0.2 would be 2. So this one's clustering around 2. This one has an average of 2. This one has an average of 5, so p would be 0.5. And this one looks like it has an average of 8, so p would be 0.8. Number 21, we have a discrete random variable, probability distribution. And it says, what is the probability that no car accidents occur in 2 consecutive months? And it does say that the months are independent. So being that they are independent, you can just multiply the probabilities. So you just do, here I got it written out, 21. There we go. Discrete random variable, independent. Anytime you want independent, you just multiply together. So if I want 0 and 0, it's probability of 0 times the probability of 0, which ends being A. Number 22. Normal probability plot. You don't got to know much about these. You just have to know that, come on. You just have to know that a linear pattern represents an approximately normal distribution. If the normal probability plot shows a linear pattern, it's approximately normal. Number 24. Which of the following is not a property of a binomial? That would be C. Each trial can result in one of two or more. The problem is the or more. Nope. No such thing as or more. It has to be one or the other. All right, so C was not a property of a binomial. 25. Let's see here. All right, I drew a little picture for this one. This is what this distribution would look like. You've got all of your area between 6 and 8. So this is a nice rectangle. And test hint, know the formula for a trapezoid. Okay, you might need to find the area of a trapezoid on your test. Okay, test hint over. So this is just a rectangle, base times height. I know the area under the rectangle is 1. I know that the base of this rectangle is 2, and therefore base times height, I can find C must be a half. So that would be A. Number 26. It says it's a binomial, and so we're looking for, in a sample of 100 passengers, I want exactly 40, so that looks like this right here. 100 choose 40. With 40 successes, and this kind of success is checking luggage. 40 successes and 60 failures, and this time the failure is not checking luggage, so E is the correct answer. Use your formula packet. This is in there. This would be N choose X, P to the X, 1 minus P to the X minus N. I think I said that right. All right, 27. Okay, 65% either have Twitter or do not have Twitter in a sample of 100. What is the mean and standard deviation, the expected value in a sample of 100 at 65% would just be 65. Okay, so C, D, or E. And then the standard deviation, you just do N times P to get that. The standard deviation is the square root of 27. Here's 27 right here. Average, standard deviation, you can see E is the answer. All right. 28, suppose that X is a random variable. That is a uniform distribution over the interval. That would look something like this. Number 28, uniform distribution from 0 to 10. And basically you're just looking for the largest rectangle, which would be E. E is this area. That would be the largest rectangle of all of these. This one's just 0, that is nothing. These are a rectangle of width 2, both of these. This is a rectangle of width 3, and this is a rectangle of width 4. Oh boy.
Student, if you have detention today, is it in room A122? If detention is in room A122.
Number 29, the key word here is the word until. That's setting up a geometric distribution. So basically I am, let's see, the number of boxes, define the X to be the number of boxes purchased. You're purchasing until a prize is found. All right, so that means what's the probability? Exactly 3 boxes will be purchased. That means you did not get a prize, you did not get a prize, and then you got a prize. So it looked like this. You did not get a prize, you did not get a prize, then you got a prize. That would be D in this category, in this problem. And this is a lot of times the way that the AP questions will be answered. And that just guarantees that you're not just going into Geo PDF and doing it, that you actually understand what's happening. Same thing here, that you're not just going into Binom PDF and just doing it that way, that you actually understand what's happening. Number 30, Normal distribution with a mean of 100 and standard deviation of 10. So I just went ahead and drew a little curve and represented 95%. So 95% accumulated area under the curve here. I just got to know what that mark is right there. That is an inverse norm. So I'm just going to use inverse norm for this. And it is possible to do this using a z-score. You standardize it, you find what the z-score is for 95%, and then you use the z-score equation to figure that out. All right, that's it. Oh man, that was quick.